There we go. Good evening. Where am I going? There. There we go. I've been disconnected from Trello, it says. We're gonna wait about for a couple minutes still, like last time. And then we'll get into things. Cool. Do. Just pull up my Twitch chat real quick. Okay. What are the sound levels are like? We got good levels. I'm going to assume so. If anyone's got feedback on sound levels, let me know. But let's get right into it. I've just heard my sister get back, and I'm concerned she's gonna jump in. Okay. So let's start off with a bit of a demo, shall we? Because I failed to post a devlog on Saturday, and I still haven't posted it. I was supposed to post it like a while ago. On Saturday would have been the time, but I failed because I've been busy. So yeah, it's still in the works. Chances are I'll probably shift over to doing maybe bi-weekly devlogs rather than weekly, at least for the rest of the year, or until Christmas period comes about, because then I'll be off work for a week, and I'll have some more time to spend on this. And I'll also, for anyone watching this back who doesn't know, I'm a musician as well, and currently working on an EP, which I'm behind on. I need to have everything done for that by the end of the year. So yeah, I've been working on that as well, which has eaten up a lot of my time whilst trying to do stuff here. But let's have a look at what we've got. How's the screen size looking for everybody? Can we see everything? Anybody? We've got radio silence everywhere. What does EP stand for? I can't actually remember. It's basically just a small album, about 5-6 songs, these days even up to 8. But I can't remember exactly what the letters stand for, but it's just a short album, basically. Zoom in on Unity. Right, let's see if I can up my screen resolution, which won't happen in sound displays. There we go. That should be a bit better. We can see the code good as well. I will rescale most of my windows once we get properly started, and we're going to use a PlayStation controller today because why not? I just got to make sure it doesn't try and use this as the sound device, because it does that sometimes. It's a bit weird. Tell you what I'll do as well. Let me just sort out some latency issues and get chats from everywhere pulled up. How is everybody today? We all chilling? Where's my latency settings? Forget it. We'll just keep going. We will go as we're going, as long as the sound levels are good. Oh, I've just seen that changing my resolution has messed up my OBS. Haha. That's a bummer. Tell you what, we're gonna just do that because I can, and it'll fix problems. There we go. Fantastic. Like how you've whacked a trademark on the end there. If only I was large enough to warrant trademarking. Right. Let's actually do things. So hit the play button here. Here's what we've got so far. You guys hearing the sound for the game and everything. I can see that there is a delay, so I'll hang about while questions or statements come in while we're running about. But yeah, just let me know if there's any issues. So yeah, we've improved the coin animations. So they're a little easier to see. You can actually notice that there's coins now, and they do a nice little floaty up and down thing at a random rate, with the currency counter in the top left as well. I don't know why I jumped over there. I need to go up here. And there's also now this little shop. You can see the signpost, and if we head in, we've got a shopkeeper that says welcome and sells various different things, which if you can't afford it and you try to buy it, he tells you can't afford it, and if you can, he says thank you, and you get a little power up. He also does this cool little lookabout, which is nice. Adds a little more of feel to the thing, which is, it's cool. It's cool. Makes it feel more alive. But we did most of this shop stuff in last week's stream, and then I finished bits off like these little pop-ups and the signposts and whatnot over the course of the week when I've had time. Question: how did I make the sounds? I used a sound generator app, which is a general suggestion for Ludum Dare or Game Jam stuff. You can see through all my files now, but it's going to be somewhere. Here we go. BFXR. It's literally just this, because I wanted to make quick sounds that would be, you know, easy temporary placeholder stuff. Yeah, they're all just little things, and you can, if I click that button, if you pick one, it just generates new sounds, and you can mess around with them. So yeah, that's cool. It's cool stuff. But today we are talking procedural level generation, because if my calculations are correct, I should be able to have an endless mode, like a playable endless mode, by the end of the year if I do the procedural level generation, death stuff, and that's about it. And then it should be playable. Multiplayer support would be good as well, but at least for, you know, being able to stick it in front of people, that'd do me good. So let's get right into it. We've got a couple of options for what we can do, and those include recursive backtracking, or doing something closer to Downwell, or how I imagine Downwell does things, in that we have set squares that will, what's I'm jigging it? Set squares that will spawn in equal intervals, and we can design all of those are custom. Pros and cons to each, with having just set random stuff that spawns as you're going up. It gives you a lot more control over how the final thing comes out, which is, you know, that's a good plus, especially from the point of view of level design, because you can spend more time actually designing the levels and making sure that they're nicely playable. You'll never end up with a level that's not playable or in a bad state. But it's less random than it could be. An issue with pros for recursive backtracking: you have more varied levels. The idea is that, if you haven't heard of it, it's an algorithm that's useful for generating mazes. You pick a place to start, and then it goes through every available tile until it hits a dead end, and then it will backtrack until it can go somewhere else, and it will cover every square in the path that it can possibly take. So I kind of want to go with something that's in the middle between those two methods, the pre-designed and the recursive backtracking. The issue with recursive backtracking is, if I have a system, basically, because it's a tower, I always want to have it so the player starts in the bottom left and finishes in the top left. So if I had a situation where the algorithm decided to go across and then straight up and to the left, or if it just went straight up and to the left, we've got like a massive column of empty space over on the right hand side of the screen, or the right hand side of the tower, which could then be filled randomly, but it doesn't make for particularly interesting play style, so we might have to think about how I can get around that. This is my ticket that I created like a while ago, which, as you can see, it says here we're going to use Spelunky style level generation, which we're not, so I'm going to delete that. The new change is that the tower will be 2 by however tall I want it to be. So it could be 2 by 10, for example, which effectively would be 5 rooms tall, because one room would be split up into quarters. But you know, we're just gonna dive straight in and see what we can do. So let's create a new C# script, and we're gonna call this level string generator. So I like to generate levels by creating a string that represents what the algorithm has done, instead of for example, Blackthorn Prod, who is a fantastic YouTuber for game design and game stuff, did a video, has done multiple videos and multiple series, in fact, on different styles of level generation. One from Binding of Isaac, the other from Spelunky, and then one for just placing items randomly around a scene. But his methods always use game objects to instantiate and delete other game objects while the level's being generated. I don't particularly like to do that because it makes loading time a little bit bigger, because you're spending a lot of time creating and deleting objects dynamically as a level is being generated, and it also just isn't as clean, in my opinion. So I like to have an algorithm that creates a string, and then I can pass that string into a level renderer, is what I usually call it. It doesn't actually render anything, but that then goes through the process of parsing that string and creating the level that we want to create. So I'm going to need a notepad for this, because we're going to have to do some tracking of what the thing does. So what I'll do, I'll create a public vector, public int depth, level depth. I've also created the string for the final level as well, and the level depth is basically just how tall the level's going to be. I'm going to make it 5 by default, because that just feels like a nice number to me. And we'll also have a public vector2 room size, which will be by default equal to a new vector2 of 10 by 10. So to explain this in the context of the game, let's make that background a bit of a nicer color as well. I don't like the default color. Oh, how do I do it? There we go, solid color, and I'll make it a grey, because I prefer a grey to the blue that Unity gives you by default. So, like I say, context for this: if I create a sprite here, just a normal square, and let's reset him to the center of the screen. This square is 1 unit. I want to make the levels that I have in the placeholder scene that I had for, you know, with the shop in it and the player moving about, is 20 by 20, which is that beautiful nice width. And what I'd like to do is split that into quarters, basically. So each room would be 10 by 10, rather than having just one room and stacking rooms on top of each other. We'll split it all into corners, so we've got two columns, so the width of the level will always be 2, and then I can set the height dynamically and it will split everything into quarters. The confusion might come in with this level depth, because in my head I want to have it just be static, the number of whole rooms that it would be, So 20 by 20 rather than 10 by 10, which means we'll need to double this for any calculations that we do for generating the level, but we'll tackle that when we get to it, which is pretty sharpish. So here we go. Public void. We'll have it as a void for now because we're storing the string. Generate level string. Like that. Now, to remember how to do recursive backtracking. We're basically going to start at a single position, which is 0, 0. So I'll tell you what, we probably want to have... Do we want to have an array? Nah, I don't want to have an array. And we actually do need this to return a string, because it's going to be recursive. So it's going to throw us an error at the moment because we're not returning anything. If I just stick, oopsie daisy, return. Okay, here we go. We'll create public void new level. And in this, we are going to do debug.log generate level string. So what we're going to do here is have basically every time we call this method. Okay, I'm going to try and explain recursion now, which is one of my favorite things. It actually is. I love recursion, but it's convoluted. For anyone who doesn't understand what recursion is, the idea is that you have a method which has an exit condition. So, for example, the exit condition for this method will be that we've reached the end of... we've covered every square in the map, so therefore we've reached the end of our level generation, and we can just return the string that we've got. If that exit condition hasn't been met, we perform some logic, and then we call the generate level method again with the string that we currently have as a parameter being passed into it. So effectively do return generate level string like that, with whatever our current string is, current string plus generate level string. So what we're going to do for this is actually going to be pretty straightforward. We will have a string next move is equal to nothing. Then we'll check. Actually, no, I'm doing this in the wrong order. Boop a doop boop boop. First of all, we check if at end of algorithm. Cool. If we're not, we then do logic to decide which way to go. And then we return next move plus generate level string. So that's exactly what we can do here. Return next move plus generate level string. And the best way to do this, I think, will be to simply say this needs to take in an integer for current position, or current room count, let's call it. So the current count of rooms that we've been to. So for the first call we'll pass in 0, and for this one we'll do current room count plus 1, because we've just done one extra room. For deciding if we're at the end of the algorithm, we're going to say if current room count is equal to, equal to level depth multiplied by 2. So the area of the map, basically. If that's the case, then we return next move. Next move doesn't exist yet. Oh, yeah, we'll return like an ending character, so a dash, like that. Current room count is greater than or equal to level depth times 2. Return a dash to signify we've hit the end of our string. Otherwise, we need to do the logic to decide which way we need to go. So, for this, if I can get my brain to think about what logic we need to do. If we start in the bottom left always, then I suppose really we need a way of keeping track of whereabouts we are. So I'll tell you what, we'll also take in a vector 2 current position, like that. And we'll pass that in as vector 2.0. Whoops, I put that in the wrong place. I probably should have said at the start of the stream, this is going to be a much more codey stream than the last one was. We did a fair bit of visual stuff in the last one, but this is going to be quite codey because we are doing level generation. Although, we could probably get this done by 9, which gives me another hour to start messing around with content. Famous last words. Right, so cool. We want to look at our current... We want to be able to pick a random direction or decide... we want to decide which directions we can go in and then pick a random direction from those. So I suppose we can always go up until we can't always go up. If we reach the top, we can't go up. So we'll say this is a weird way of doing it. I'm going to create a list of chars called move options equals new list. I can see this getting very messy very quickly. Suggestion of if this way, go the other way. There's definitely a limit to how big the maze can be, because of the stack in the computer. If we end up with too many recursions, it'll run out of memory and crash, which we don't want. But it can go pretty big, thankfully. Much bigger than we'll need for this. Using to compile is just Unity, sir. It's got its own compiler inbuilt. I need to be using a stack is what I need to be doing. Need a public stack of... Oh, how did I do this? I've done this before. Yeah, that's effectively what I'm gonna do. The issue is that there aren't physical adjacents as such. The because there's no objects. I could make an object to represent a room if I wanted to, but I don't, because it should all be one object by the end of things. So to explain the problem a little better, we basically just need to say if we're going to move out of bounds, or if that place has already been checked, then I'm going to have to make physical rooms, aren't I? See, what I'm going to have to do is refer back, way back, to the Dark Ages, aka when I did my A-level computer science, which is going to be in here somewhere. Oh, I am so glad that I kept a copy of this. Computer science coursework, here we go. So somewhere in here, we've got this nice lengthy evidence of iterative development. Oh man, this is the throwback. But somewhere in here, now you can see here I've got Spelunky and Binding of Isaac in here as well. There should be the code I used to do procedural level generation. It might be in a different one of the copies. This one? World generation, page 27. 25, 26, 27, 28, 29. This isn't my code. Where's my code? Because then I can just nab it. I'm going to have it in here somewhere. That's the story for the game. That's the proposal. Did I look at that one already? It's got to be this one. It's got to be this one. Yeah, here we go. Here we go. We're back in business. Went too far. Oh my gosh, I did a lot. Here we go. So this is an example of one of the worlds that I generated using this algorithm that I had. So effectively we've got each of these black spaces represents a position in the grid, where green shows a route that it's gone through normally, and red shows where it's backtracked. So that's how we passed that seed. One represents moving. That's how I did it. I had it so that it had a set of directions it could move in, and then it prioritizes them going clockwise. So 1 would be the first option, 2 would be the second option, 3 blah blah blah. I think 0 is left. So 0 is left, 1 is up, 2 is right, and then 3 would be down. Oh no, that doesn't make any sense. Tell you what, I don't understand how my code works, but that's okay. We'll break it down when I copy and paste it. Oh, look at that. So yeah, I created a class for a room. Oh no, is the code going to be gone because the images have disappeared or something? Or are they just going to be really weirdly out of place? There's a room stack, room class, and then there's the actual level generator. It's all actually pretty straightforward. Tell you what, let's pop this open in Pages. And we're going to do a tile to the right of the screen with that on the left hand side. Let's just make sure that the stream picks that up. Good. How's everyone coping so far? Is this cool? Have I fried anyone's brain yet? With poor explanations. Oh, I'm just seeing how massive the delay is between Twitch and YouTube. I'm gonna have to sort that out. Okay, let's get straight into it, shall we? So our level string generator is basically going to be replacing this class, which is the path generator class that I created. The idea... Look at how low res that is. That's going to be fun to try and pick apart. That's going to be so much fun to try and pick apart. Look at that. It's literally pixels. Thankfully for us, it was compulsory to write this horrible little thing called pseudocode. So there should be in here somewhere some massive red text representing pseudocode. To go back to the question earlier about how big can the map be though, here's a grid of 30 by 25 using this, and it works fine and took not very long to generate, and we're not going to be going anywhere near that size. I feel the biggest depth that might be covered is maybe 10, so effectively 20, so it would be 20 by 2, which is 40, rather than 30 by 25, which I can't do in my head. So we'll be fine. We'll be fine if I can find my pseudocode. Tell you what, oopsie daisy. Let's sort out my desktop, shall we? Right, new script. We're going to create a C# script called room. And we're going to create a C# script called room stack. Oh, yes, it did do it. Thank goodness. It was lagging for me a bit there. I'm going to do a bit of tidying up as well, create a new folder called level generation, and we'll stick all of our level generation scripts into this folder. So that's room stack, room, and level string generator for the time being. We'll also have, like I say, the path renderer or level renderer, and we'll stick that in there. Possibly later this stream. Potentially not though. Okay, let's do it. Room. Gonna start by cribbing that first. Oh, here we go. Look at this. That's the 20. That's the seed created by the 25 by 30 grid. It's very long. Very long indeed. So possible, but not worth it. We'll end up with some quite long strings if we go too high. All right, let's check this room script. So first things first, we've got a private list of type room, which is adjacents. New list of type room. as suggested before, and a private list of connected rooms. That room again called connected rooms, which I'm not sure what that is for off the top of my head. It's going to be an interesting learning experience for me and you guys. Have a list of vector2s for path positions, which is actually, I'm going to rename that to room positions because that's a better representation. New list. New list of vector2s. Get my brackets in there. I'm trying to type without hitting my microphone. There we go, that's better. Can people still hear me alright if I'm this far away from the microphone? Anyone watching on YouTube? Maybe, because there's less latency there. Is the room already traversed? This is an important bit. We need to make sure that we check if a room has already been entered by the algorithm, because we don't want to be going back to it again unless we're backtracking, which works differently. We'll get to that when we get to it. So we're going to have a private bool is taken, which is equal to false by default. I'm also going to get rid of this mono behavior extension because we're not going to be creating instances of this room in the game. They're only going to be used for the actual generation of our seed. And then position in world space, which I'm not going to worry about for the time being. I might do things differently. So we need a public void set taken. It's going to take it. It's not even going to take in anything. We're just going to say taken is taken is true. And we need a public bool is taken, this time with a capital I, and that is going to simply return is taken. Public void, yeah, void, add adjacent. It's going to take in a vector, no, it's going to take in a room adjacent, stop, and we're going to say adjacent dot add adjacent, and then a public void add connection, we'll roll with it. We'll add room, no, it should be connection, connected coord. Let's do that. Vector2 coord, and we're going to say room positions dot add coord. And finally, that public room array get adjacents, which is going to return adjacents dot to array. Missing brackets. There we go. Room done. Let's open our room stack and see if I can read what it says. Whoops, don't want to zoom in there. I want to zoom in here. There we go. So this is effectively just a stack, but implemented by myself. So we don't even really need this particularly, but I'm going to roll with it just because I know it works. Pos represents the current index of the stack array, and then we'll have a public room stack. Constructor takes in a size, then room stack equals, it's going to be a new array, oops, not tomb, room of size, stack size, public void, not void, room pop. For anyone who doesn't know what a stack is, this just returns the thing on the top of the stack and removes it from the stack as well. So current pos is going to be minus equal to 1. Room temp equals room, nope, not minus, equals room stack at current pos. Room stack, whoops, at current pos is going to be equal to null. Reset it to nothing, and then we're going to return temp. So decrease the position from being where we want to insert something new to where the top of the stack is. Set a temporary variable to what that value is. We're then going to set what's actually there to be nothing and return the temporary object that we created. And similarly, we'll have a push method which takes in a new room to add. I wasn't even looking at my code, and that's what I call it in there as well. Room stack at our current position is going to equal our room to add. Nope, not the room stack, room to add. And then we'll increase current position, current pos plus plus. Nice and easy. Right, let's try and do this actual level generation now that we have a thing. I want to see if the pseudocode is in here anywhere. Because I know that it will make life a lot easier if I can read. Okay, that's menu stuff. Yeah, by the looks of things, my pseudocode. Haha! Look at that. That's just a bit jammy, really, isn't it? Let's make that a color that we can read. Not that color. Don't highlight it. Don't highlight it. Okay. Where's my format window? Why am I in preview? I don't want to be in preview. I want to be in pages. Hey, there we go. Oh, look at that. Beautiful code. Let's full screen this so I can see what's happening. And we'll sort out these windows as well. Make sure I've got all of this stuff here. Let's close that because I don't need that open. There's that one. Tile that to the left, right even, and stick that next to it. All right, we're back in business, ladies and gentlemen. Typo there. So our grid size, we're not actually going to have a grid size. Like I say, grid size will always be 2 by whatever the depth is, and the room size is representative of how much space we need to leave between things. So that means that we can also have rooms that are a different height as they are wide. So, you know, if I decide that I want to make it more rectangular, that's perfectly feasible. So I generate grid. So I'm actually creating a full like physical array of rooms to sort through, physical grid of rooms, which I suppose makes sense. So we can keep this new level method to call that. Yeah, let's go with it. Let's go with it. Public room grid is going to be an array of rooms. I'm gonna have to make sure I'm switching nicely backwards and forwards between my pseudocode syntax and actual code syntax. So it's going to be a 2D array. 2D array of rooms, which is the room grid representing what is what. So that room grid is going to be equal to new room, which is 2 by level depth multiplied by 2. Makes sense. We need a room stack. I'll stick that here. Private room stack iteration stack, I'm going to call it. So this is going to be the stack of rooms that we iterate through in our generation algorithm. Our current iteration is this room count variable, which is always going to start at 0, and we can check in there just by passing it in. We've got our level string, which is the same as this region path seed, and that's all good. This might be where the room coordinate stuff comes in handy, because I am setting the coordinates of a room to know its position, although I don't think we actually need to know that because we have a 2D array, so we can just go by the index. I think that works for me. Yeah, the issue then comes in with adjacents. We need to set all of those adjacents. So we'll need to do a for each room in room grid, because we've just initialized that now. That's a new room, new array of empty rooms, effectively. So for each room, we need to just do these if statements. If room dot, oh no, yeah, okay, change the style a little bit. Maybe I do need those coordinates. Maybe I do need those coordinates. It'd certainly make life a bit easier. Yeah, we can go with it. For in x equals 0, x is less than 2, x plus plus. For in y equals 0, I'm missing a semicolon up here. And y is going to be less than level depth times 2, y plus plus. No space needed there. Whack in those. We are going to say if x is equal to 0, we'll say room grid xy dot add adjacent room grid x plus 1 y. So if our room grid is at 0 on x, then we can add the square next to it to the right as an adjacent, else it'll be the square to the left of it, and that goes without saying. That's guaranteed.